The engine block is the largest single piece of metal in a car, and also one of the most intricate. It houses and links all the engine components, such as the cylinders and pistons, and it contains passages for circulating coolant. The engine block is where combustion converts into mechanical energy that drives the transmission, propelling the car. Engine blocks used to be made of iron. Today, most are made of lightweight aluminum alloy for fuel efficiency. An engine block is a one-piece component cast from a sand mold. To make the mold, the factory mixes glue and a hardener with zircon sand. This combination of materials can withstand the intense heat of molten metal, but only for one casting. Each mold is made up of sections called cores that fit together. To make each core, a machine blows the sand and glue mixture into a master mold made of iron. It injects a gas that activates the hardener, which solidifies the mixture. This is the base core to which the other cores will attach. The base core travels down an assembly line to receive the other cores. The next core molds the engine block's cylinder bores, which will house the motor's pistons. A robot inserts iron liners into 6 holes in the core. They prevent the aluminum walls of the bores from wearing out from abrasion. The base core receives 17 other cores. The ones for engine block areas through which oil will flow are coated with talcum powder. This keeps sand particles from sticking to the aluminum and getting into the oil. The machines glue certain cores so they'll stay intact when the robots flip them upside down and attach them to the rest. These are the last 2 cores. The mold is now fully assembled and ready for casting. Workers load aluminum ingots into a device called an elevator bucket. It positions them above the jet melter, a gas-fired furnace. The bucket drops the ingots into the 800 degrees Celsius fire, liquefying the aluminum. Just before casting, they heat the cylinder bore liners using high-frequency electric current. Aluminum will bond better to hot metal. They fill the molds from the bottom to avoid contaminating the metal with aluminum oxide. Oxide forms when molten aluminum comes into contact with the air. Pouring into the top of the mold would expose the metal to oxygen, and the pouring action itself would mix in the oxide. After the casting, the molds spend 6 hours in what's called a thermal sand reclaim oven. That breaks down the glue so the sand falls away. The heat also strengthens the metal. The cast aluminum engine blocks emerge, needing just some minor finishing. Robots turn them upside down to spill out loose sand. Machines saw off the risers, extra metal that fed the mold cavity to compensate for the 7% shrinkage that occurs when liquid aluminum solidifies. Finally, computer-guided tooling equipment performs a rough machining of the metal. This brings the engine blocks to a near-finished state. The engine plant that buys them does the final machining before installing the engine parts.